Okay, so now we can say that this is equilibrium. Okay? It's equilibrium because this says that the total force in the y direction is 0, which means that the acceleration in the y direction is 0, so that's a Newton's first law equilibrium situation. And I should probably use a capital N on the F just to be consistent, right? In the x direction, so these are the y forces. Now this is assuming there's no friction, and we'll deal with the case of friction once we're sure everybody's got this. Okay? In the x direction, mgi is the net force. Another thing about the y direction, I just mentioned that the acceleration is 0, and of course this is a consequence of this. Okay? Okay, now back here, we have this, right? Well, there's no net force in the y direction, there's this net force in the x direction, so the whole net force is this, right? And this says then that so the acceleration is gx times I, right? Now we go back to the equations for gx in terms of theta, but this is true no matter what the angle is, so I didn't even bring the angle into the consideration. Okay? So in terms of the mass m and theta, our normal force is negative the mgy times I, right? And the mgy is this. So this is the negative of mg times the sine of 270 degrees plus theta, right? And that equals and this is times j, not I. mg cosine theta times j. Because the sine of 270 degrees plus theta is a negative of the cosine of theta, which is very easy to see if you ponder the circular definition that we need for rotational motion and everything else in this course. Okay? Did I say circular motion? Circular definition. Okay. I don't know what I said. Okay. Then the acceleration is gxi, which is mg cosine of 270 degrees plus theta, which is mg sine theta, which is something you probably just memorized in statics. Doesn't work well if the graph inclines to the right and your x-axis is up the incline. It's not mg sine theta, it would be negative mg sine theta, which would come out of this, and which should then reconcile with your intuition. Okay? Now there's intuition involved and drawing the triangles and stuff, which I'll probably do next time or maybe in Lab Friday. Okay? It's still important to understand that, but you're going to screw up the signs less often if you use this. because it's real easy to screw up your signs. Easy to put a negative down where it should be positive, or vice versa. Okay? So it's not as rigorous or reliable the other way, but it's not as intuitive necessarily to be using these expressions. So you really kind of want to do both, but I'm emphasizing these because everybody wants to do triangles. Okay?